Yes. Here the question is to find the heat dissipated in 1 second in each of the following circuits. So which formula comes to your mind? Perhaps that must be Joule's law of heating, which says heat produced when I ampere current flows through a resistance of Rho in T seconds is given by H is equal to I squared RT. But current is not provided here. So we can go for some other formula. But let me discuss with the same formula. We can find the current and we will try to solve it. Okay. In the first case, the resistance is 3 ohm. Second case, resistance of the circuit is actually 1.5 ohm because two 3 ohm resistors are connected in parallel. Then equivalent resistance will be half of 3 ohm. You know that. Here these resistors, in the case of 2 3 ohm resistors are connected in series, so total resistance will be 6 ohm. Well, one more thing we can take, the current flowing through the first circuit, it will be I1, and the current flowing through the second circuit, I mean the current drawn from the cell, that is I2, and the current drawn from the cell in the third case is I3. I will find this I1 first. I1 is equal to, you know the formula, I is equal to V by R. So here V by R. So what is V? V is 6 volt and R is 3 ohm. So current drawn from the cell in the first case is 2 ampere. What is the current drawn from the cell in the second case? I2. I2 is equal to 6 volt divided by R. Resistance is 1.5 ohm. So here the current drawn is 4 ampere. Third case, current drawn, voltage is same only, that is 6 volt. Resistance is 6 ohm. So current drawn is only 1 ampere. Well, then I can find the heat dissipated in the first case. So H1 is equal to, formula is I squared RT. So shall I write this current here? That is 2 squared into R. R is 3 ohm into time is 1 second. So here it is 4 into 3, 12. Okay, 12 joule of heat energy is dissipated in the first case. Second case, heat dissipated is equal to, again formula is the same, I squared RT. So I will say 4 squared, R is 1.5 into time is 1, that is 24 joule. Third case, heat dissipated is equal to I squared RT, that means 1 squared R. R is what? In this case that is 6 ohm. 6 into 1 second. Okay, so here heat dissipated is 6 joule. So this is the answer. But in fact, this was not the question I wanted to ask you, or this is not the way I wanted to explain this. The real question is something else. Shall I go for the question? Yes, this was the actual question. You are given 3 circuits. Identify the circuit with the minimum dissipation of heat. Time is not given. But now you know the answer. The minimum heat dissipation is in the third case. We have already seen that. But it is not necessary to go for our formula H is equal to I squared RT. Here just you have to find the rate of heat dissipation. Rate of heat dissipation means energy dissipated per second. That is nothing but power. To find electrical power, you have got many formula. One is P is equal to I squared R. But I is not provided here, so we don't go for that. One more you remember, power dissipated is equal to V squared divided by R. Okay, we will go for that. So power dissipated in the first case. Power dissipated means the heat dissipation in 1 second. Okay. Power dissipated in the first case, formula is V squared by R. So here it will be C squared by resistance. That is equal to 12 watt. Power dissipated in the second case, again V squared, that is 6 squared R. R is 1.5. So the here power dissipated is 24 watt. The third case, power dissipated is equal to, as you understood, C squared divided by resistance is 6. So this is 6 watt. So this is what we have already got. In fact, we have seen that energy dissipated, heat energy dissipated in case 1 is 12 joule in 1 second. And heat dissipated in case 2 is 24 joule in 1 second. Heat dissipated case 3 is 6 joule in 1 second. So what is the answer of the question? The circuit with the minimum dissipation of heat. So your answer is case 3.